Lesson 6.1, Graphing Quadratic Functions. The first way that we're going to talk about graphing quadratic functions is the most simple way, and that's using an XY table, or in this case, an f of x table. You can use your calculator to graph this, and I'll give you an approximation of where things are. But let's just start with the basic idea that we should always plug in negatives and positives. So I don't know where this parabola is, but we're just going to go with a symmetrical perspective here. If we plug in -2, we are going to square -2. So remember that we need parentheses on our calculator to explain that to the calculator. And 3 times -2 minus 1. All right, that will give us a +4. -2 quantity squared is +4. Minus 6 minus 1, we get -3. We plug in a -1, and that gives us 1 minus 3 minus 1, so -3. If you plug in a 0, we'll end up with -1. We plug in a 1. I'll give you 1 plus 3 minus 1. And you plug in a 2. I'll give you 4 plus 6 minus 1. Now if we graph these, one coordinate will be -2, -3, and then -1 also gives us -3, 0 gives us -1, 1 gives us 3, and 2 is off the chart. Now we know that y equals x squared is the parent function for parabolas, and that one is centered over the origin, opening upward. This one has been moved. Now if you notice, this would come down. I don't know where yet, we're going to learn that later, but it would come down and go back up like that. We know that parabolas are symmetrical, so we would have what looks like a line of symmetry basically right about here. Therefore, that would explain why these 2 points sort of mirror each other. This point would mirror itself over here, and so on. This point would mirror itself over here. Notice that in terms of vocabulary, this point, 0, -1, would be considered the y-intercept, and for purposes that we'll see later, notice that it is the constant of our function, a number without a variable. Now let's take a look at this function. This function is not in standard form. Standard form would put the highest power first, so that would be x squared minus 4x plus 2. Now, as we mentioned on the previous page, the y-intercept will be 2, the constant. The axis of symmetry is a formula that's in your books that says x equals -b over 2a. A and b come from the coefficients of our quadratic function. So a is 1, b is -4, and c is 2. And we must keep the signs with them. With that in mind, our axis of symmetry would be -b, which is -4, over 2 times a, which is 1. This will give us a +4/2, in other words, 2. So our axis of symmetry is x equals 2. That's a vertical line, and that will split our parabola in half. The x-coordinate of the vertex is going to be the same as your axis of symmetry. In other words, 2. Since your axis of symmetry goes through the center of the parabola, it is automatically going to go through your vertex of the parabola. That's why the x is 2. Now here we're going to make a table that includes the vertex, meaning we need to have an x of 2 in there somewhere. So let's go, let's say, -2, -1, 0, 1, and 2. So here's our, this is including our vertex. We plug those points into this function as we did on the previous page. We would get, and I'm going to write it in this manner. So we would have 2 minus 4 times -2 plus -2 squared. So 2 plus 8 plus 4. That will give us 14, definitely off our charts. We plug in -1. That's a -1 there, sorry about that. That will give us 2 plus 4 plus 1, which is 7. We plug in a 0, we're going to get our y-intercept, and that will be 2. Plug in 1. That will give us 2 minus 4 plus 1. That's -1. We plug in a 2. We get 2 minus 4 times 2 plus 2 squared, which is going to give us 2 minus 8 plus 4. So -2. Now, what is this going to look like if we graph it? Well, first of all, we have a y-intercept. The y-intercept is 2. We have a line of symmetry, or axis of symmetry, which is at 2. Okay, the arrow goes down, but it can go up and down. That is, it's just a mirror point for us. And then we will plot the vertex. So the vertex is when x is 2, the y is -2, so this is our vertex. And from there, everything will mirror. And I'll stop here, and I'll call this the end of part A.